Welcome everyone to the deep dive on Active Directory from one to many regions session. We're very excited and glad to have you guys with us. Thank you for joining our session this morning. My name's Lou Delatorre. I'm a solutions architect with AWS. I've been with AWS now for about 3 years, and I'm responsible for assisting partners and customers alike with their Windows migration strategies to AWS, as well as their Windows architectures on AWS.
Good morning, everybody. My name is Vinod Madabushi, and I'm a solutions architect with AWS as well. I help enterprise customers with their cloud strategy, as well as architectural advice on how to build highly reliable, scalable, and resilient architectures on AWS Cloud.
Thank you, Vinod. So today, the focus of our session is going to be Active Directory domain services on EC2. And this is a great use case for customers that want to deploy a single forest, single domain across one or many different regions within AWS. It's also an excellent use case for customers that want to deploy enterprise applications like Exchange or other applications that may require elevated permissions or access to certain containers within AD that may not be available within Directory Services Managed AD. Now, if you were hoping to get some information on Managed AD, which is our Managed Microsoft AD service offering, there is another session that's going to be taking place this week. It's Directory Services, and it's a deep dive on Managed AD, and they'll go deep into Managed AD there. But again, the focus of this session today is going to be Active Directory domain services on EC2, because we have many customers that want to deploy it for the use cases that I just mentioned. So we'll talk about the importance of ADDS on AWS in the cloud. We'll look at some things that you need to take into consideration when you want to deploy Active Directory on EC2 and AWS. And then we'll show you how easily you can deploy ADDS on AWS from one to many different regions. Now, before we discuss the why and the how, we must first level set on the what. What exactly is Active Directory? Now, how many of you here have experience with Active Directory? Perfect. So I don't have to spend a lot of time on that, so I'll just skim right through that. That's exactly what we were hoping this session is intended for you guys. But again, we just want to level set that this session is going to focus on domain services. There's many other roles and features, as you know, within Active Directory. There's federation services, there's certificate services, rights management services, lightweight directory services, and we're not really going to go into those. We're going to focus on domain services because that's the most commonly used role on AWS. So as you know, Active Directory domain services is both the information source and the service that makes that information available and usable. So essentially, it is a phone book. Now, why is ADDS important? Well, because, as I mentioned, it's the information source that you're going to be able to use information such as users, account information, privileges, profiles, policy management, also information on your servers and workstations, as far as domain joins, policies, network information, as well as application information. For example, your Exchange servers, mailbox information. So all that is contained within Active Directory, so it makes it very important in the cloud. Now, as you know, the cloud is the new normal. So enterprises of all sizes are migrating their Windows workloads to AWS. And as they migrate those workloads, they also have to provide the infrastructure required to support it, including ADDS. And we have many enterprise customers that are doing this today, and therefore providing low latency access to their applications for authentication services. Now, the majority of this talk is going to be to help you self-serve yourselves basically in leveraging AD on AWS. But we know that many of our customers are limited in resources. They have time constraints that they're dealing with. So please take advantage of our large partner ecosystem. We have many partners that can help you with your Windows designs, your migration strategies, and your Active Directory domain designs on AWS as well. We have partners like Cognizant, Second Watch. You see them all listed there. We also have competency partners that specialize on databases like SQL Server. For example, partners like DataVal, CorpInfo, RingCloud, and Reliance. And then we have productivity partners like DataPipe and InfoReliance that can help you with your productivity apps like SharePoint and Exchange. So definitely take advantage of these if you need some additional assistance with your deployments on AWS. Now, some common deployment scenarios for Active Directory on AWS include things like global deployments. So if you have a company that's a global company and you have a data center in the US that serves users and services or applications that may be dispersed around the world, yet you don't have the data center infrastructure to support that, it's not going to be the most optimal performance and the most efficient access to your resources. So in the past, this has been very costly to deploy. Well, now with AWS, you can simply deploy an EC2 instance, let's say in the Asia region, for example, enable Active Directory domain services, and now allow your users and services to access the authentication services locally and therefore improve the performance of your users and applications. There's also DR, for example, whereas in the past, again, deploying multiple data centers was costly just to support DR for your applications. Well, now you can simply spin up a EC2 instance or instances in a VPC in a region and enable that as your DR site and therefore minimize the cost of running that in the cloud. Enterprise applications. Maybe you have an enterprise application that you need to isolate. You don't want to run it in your own data center. You want to provide maybe customers access to it or external users access to it. Well, you can leverage the cloud for that. Deploy that application in the cloud, isolated from your corporate network, and allow those users to access that remotely. Or if you require hybrid connectivity, maybe you do need to connect it to your internal resources. Maybe you want to leverage some existing applications you have in your own data center. Well, you can provide the connectivity to allow for that type of solution within AWS for hybrid deployments. So now that we've talked about why customers are choosing AWS or deploying ADDS on AWS, let's talk about some of the considerations for deploying ADDS on AWS. Now, the fundamental requirements for deploying Windows Server Active Directory on EC2 or virtual machines really differ very little from deploying it in your own on-premises data center. For example, in the case of Windows Server ADDS, if the domain controllers that you're going to deploy in the cloud are an extension or replicas of your existing Active Directory that's on-prem, well, you would simply deploy it in a VPC, install the EC2 instance, enable it as a domain controller, set that up as a site, set up your site links and so forth, just like you would any other data center if you were deploying Active Directory to an additional data center. So it's pretty similar to your experiences in deploying it on-prem. However, there are some considerations that you want to keep in mind when you deploy it on AWS. So we're going to talk about those over the next few slides. First, we're going to start with some common general design considerations. So you're all familiar with this shared responsibility model within AWS when it comes to security. The same thing applies to Active Directory. So AWS is responsible for everything from the ground to the hypervisor, and the customer is responsible for everything from the OS on through the application, including Active Directory. So that being the case, you have to keep in mind your patching. How are you going to patch those Active Directory domain controllers? How are you going to monitor them? How are you going to back them up? Those are things that you may already have solutions for on-prem, and you can certainly continue to leverage those existing solutions on AWS. But there are services within AWS that you could potentially leverage. For example, for patch management, we do have a service called Systems Manager, which has a patch manager capability. And you can leverage Patch Manager to patch your domain controllers and any other Windows or Linux instances that you may have in the cloud. And by the way, it can also patch and manage your servers that may be running on-prem or any other cloud provider. Additionally, you want to make sure that you have monitoring in place, so leverage CloudWatch. If there's some additional features you're looking for, we have a slew of partners out there that can help you with your monitoring as well. Backups. If you have an enterprise backup solution, you can leverage that. Otherwise, leverage Windows System Backup, and we'll talk a little bit about that in the next few slides. Most importantly, you want to ensure that your ADDS is highly available, so leverage multiple availability zones within AWS in a region. So place domain controllers in a minimum of 2 availability zones so that you have high availability, and treat those availability zones as you would distinct data centers. So availability zone 1 being one site, and availability zone 2 being another site, so that if you have applications running in those availability zones, they have domain controllers local to them that they can leverage. What about security? Well, again, there's a shared responsibility model, so there's definitely the AWS services and access that you want to keep in mind, but there's Active Directory best practices that you may already be familiar with that you want to continue to leverage. For example, you want to control access to your domain controllers. So if you have a cloud team that's responsible for deploying your AWS services and resources, and you have a separate domain administration team, you want to continue to have that separation of duties between those two. So you can control access for your AWS services and resources via IAM roles and policies, and control access to your EC2 instances, your domain controllers, the operating system, via your security group memberships within Active Directory. Also, domain controllers should never be internet facing. You want to put those in private subnets and ensure that they're not accessible from the internet. And leverage NACLs and security groups to control what ports are open within Active Directory, providing the communication required for the domain controllers and the member servers to be able to access the services and the ports that they need, but restricting that based on your security policies that you may have. Now, what about networking? Well, as with any Active Directory design that you may have been involved with before, you know that you need to understand your networking infrastructure prior to coming up with an appropriate design for Active Directory replication topology. So it's important to understand your connectivity options. Understand if you're leveraging an on-premises environment, what that looks like from a network connectivity perspective. Is there an MPLS network, for example? Do you have multiple locations around the world that you're using with multiple data centers, branch offices? And then what does that connectivity look like into AWS? Do you have direct connect? Are you using VPN? Or is this going to be a disconnected environment? All that is going to help you determine how to set up your sites, your site links, any bridges that you may need to put in place to control and manage your replication. If you notice on this particular diagram here, we have a sample or a common architecture where you have an on-premises data center, multiple data centers, one in Seattle, one in Tacoma, each with their own domain controllers. And then you have an extended AD into AWS with domain controllers in each availability zone. Notice that the costs for replication are lower for those servers within the same region or location, and they're higher going across what you can consider your WAN links, for example, or your direct connect or VPN connection. And that's to ensure that they're replicating with the closest domain controller possible and avoiding any unnecessary replication over the higher cost links. So this is all determined on how you set up your replication topology and how the KCC develops those connections with the domain controllers. One additional note to keep in mind here, when peering multiple VPCs, it's enough just to deploy DCPs in a single VPC and make that, for example, a shared services VPC. And then your application VPCs that are in the same region can peer with that shared services VPC and leverage that for authentication services. So that is also an option for you if you're deploying your applications in different VPCs and want to minimize the amount of infrastructure required to support them. Now, IP addresses and DNS are also important to take into consideration. When an EC2 instance is launched into VPC, a reserved private IP address is automatically assigned by the DHCP service within that VPC. It's common practice to configure or define separate subnets just for Active Directory for those instances to use, or use common services subnets to deploy domain controllers. And when you're installing member servers, you want to be sure to configure the network properties with the name and IP addresses of the servers or the EC2 instances running ADDS so that they can resolve the DNS names appropriately if you're leveraging Active Directory integrated DNS and authenticate against those domain controllers. Now, we do have a feature called the DHCP Option Set, which automates that configuration for you. So you don't have to go into every server that you want to make a member server and configure the network properties for. Instead, you would leverage the DHCP Option Set, and with the DHCP Option Set, you can specify things such as the domain name servers, NetBIOS name servers, for example, and this will automatically configure your EC2 instances when they're launched within that VPC, and that just makes it easier for them to be able to domain join to your Active Directory. So definitely take advantage of DHCP option sets. Now, if you're deploying ADDS into multiple regions, there's some things to keep in mind with that as well. Even though you have a domain controller in multiple regions, you still want to have high availability within that region. So still you want to place at least 2 domain controllers in multiple availability zones in, let's say, the US West 2 region, and 2 domain controllers in multiple availability zones in the US East region, for example. So ensuring high availability. It's also recommended if you have a data center that has a large infrastructure and you want to set up hybrid connectivity, to leverage your data center to reduce the AD replication latency. So similar to the diagram we saw previously, establishing your costs, but using your on-premises data center kind of as the hub there, if you're able to leverage it. If you want to enable replication across domain controllers within AWS and use AWS as the backbone, which also you can do and is supported, then set up IPsec VPN tunnels between those VPCs in the different regions. You can also configure transit VPCs in each of those locations in those regions so that replication can occur over those transit VPCs. And in that way, you're using AWS as the backbone for your replication versus using your on-premises data center as the backbone. But either way is supported. It just depends on your networking infrastructure. Again, the networking considerations to determine what would be the most optimal configuration for your environment. There's multiple ways to deploy domain services as well within AWS. You can deploy a separate forest without any trust. Again, connectivity between regions should be established, so that means setting up an IPsec tunnel and ensuring that AD replication is taking place across those domain controllers, and we'll show you an example of that in the demo we have lined up for you after we cover these slides. You can also deploy new forest with federation, so for any claims-aware type applications that don't require a forest trust but can leverage federation, then certainly that's an option. For those that do require, let's say, Kerberos, then a forest trust is also an option for you. Maybe you have an on-premises data center. You want to treat AWS as a resource domain, for example, then you might establish a forest trust and provide single sign-on connectivity into that environment. Or, which one of the most commonly used patterns is simply extending your Active Directory into AWS. You already have an Active Directory environment set up on-prem, Treat AWS, if you're going to maintain a hybrid configuration, as an additional data center, and simply extend Active Directory and deploy replica domain controllers into AWS. For global catalogs, of course, if you have a single domain forest, then just make all your domain controllers global catalogs. For multi-domain forests, there are some things to take into consideration as far as which servers are enabled as global catalogs and for what reasons. There may be security implications that you may have that may determine whether or not some servers are enabled as global catalogs, depending on your configuration. There may be some limits with your bandwidth. Perhaps you're using VPN or something, but still, in that case, you still could leverage global catalogs. Bandwidth is not necessarily one that affects many deployments, but the infrastructure operations master role is something to keep in mind in making sure that you set up those global catalogs appropriately so that there's no incompatibility there. Now, in deploying domain controllers, you have several different options. The first and easiest, of course, is just deploy an AMI EC2 instance with Windows, and then enable it as a domain controller, either using PowerShell or using Server Manager, DC Promo it. You also can import your own hardened VM. So if you have an on-premises golden image that you want to use as the basis for your domain controllers, then use VM import to import that virtual machine from your on-premises environment into AWS, and then enable that as a domain controller so that it has whatever it is you need in that hardened image. We also offer a service or solutions called Quick Starts. If you're not familiar with those, I would encourage you to take a look at them. I'll show you a little bit more about that a little bit later. But Quick Starts can automate the whole deployment for you, from the infrastructure being built out, including the VPC, everything in the VPC, to actual Active Directory being deployed and enabled, sites configured, all within AWS in a matter of a couple hours. And you just fill in some information, click next, and it goes off on its own using CloudFormation as a backbone to enable that for you. So what about backup and recovery? So first, we encourage you not to use snapshots for ADDS. The first one, actually, we need to remove the crash consistency, because we just announced that we support VSS for Windows workloads on AWS. So that's not a reason. That's no longer a reason why not. The main reason is because the VMID is not supported in Amazon EC2. So if you were to take a snapshot of one domain controller and then restore that snapshot, it's not aware of itself being a VM, and therefore it can cause problems within your Active Directory. Perhaps you're familiar with this in prior years and your hypervisor deployments. It was something that you also had to be careful of, except now many of those hypervisors support VM Gen ID, so it's not an issue for them. And that's something that currently is not supported on EC2. So instead, you can leverage Windows System State Backups or leverage your enterprise backup solution, and then create backups of those on, let's say, an EBS volume, and then snapshot those volumes to Amazon S3, and perhaps leverage Glacier for long-term retention. So there's still a way for you to take those backups, snapshot them to S3, and then retain them for longer periods of time. Now, I mentioned we weren't going to talk about federation services, and we're not going to go into federation services, but this is a common ask from customers. How can I leverage my existing Active Directory on AWS and integrate that with Office 365? So we're just going to briefly mention what the high-level steps that would be required to enable this, and it's absolutely supported. So the first thing, of course, is you need to have Active Directory on EC2, which we've been talking about now for the whole session. So with that being enabled and running on AWS, the next step would be to launch an EC2 instance running Windows, enable that as your ADFS server, install another instance, and install the AD sync tools on that, and create your service account for ADFS, establish connectivity between ADFS and Azure AD, and then with AD sync, replicate your Active Directory users from your Active Directory environment into Azure AD. And with that in place, now you can, with your Office 365 subscription, now you can allow your users in AWS to single sign-on to Office 365. And by the way, this is also supported in our Managed AD offering. So now that we've talked about the considerations for deploying Active Directory on AWS, I'm going to turn it over to Vinod, who's going to talk about some deployment options.
Thanks, Lou. So Lou talked about a lot of considerations for deploying Active Directory on AWS. We're going to look at how some of those fits into our design, and we're going to start with how the deployment model looks like, starting with a single VPC, and we're going to go to a multi-VPC, multi-region design, and show you how you can design this to be a globally available AD. So let's start with the first example here. So this is an example of a single region, single VPC. So this example assumes that maybe you're operating in a single region today, maybe you have one VPC, or maybe you have Microsoft applications that only need AD that's contained to a single VPC. This is the most simplistic design, right, we can start with. The first question in this is, do I extend my AD forest or do I create a new one? And that choice is totally up to you. We see both design patterns, so you can do either one of the options when it comes to the Active Directory itself. But if you do choose to set up a new domain or extend your domain, make sure that you have robust connectivity from your data center where you're running Active Directory to AWS. And there are many ways to actually do those, right? So you have Direct Connect, you have VPN, you can leverage a combination of those options to make sure that you have highly available connectivity to AWS. The next thing, as Lou mentioned, is the multi-AZ, right? So definitely deploy at least 2 domain controllers in multiple availability zones. We have regions that have more than 2 availability zones, so in those cases, you can either leverage a minimum of 2, or if you need more than 2 domain controllers, you have the choice of either deploying more domain controllers in 2 AZs, or maybe use 3 or 4 AZs as you wish. The other important thing when it comes to this is site services and subnets. The member servers detect where the domain controllers are and talk to the nearest domain controllers using sites and services. So we want to make sure that we define each of the availability zone as a separate site and place the domain controllers in that site and define the subnet and associate them with the same site. What this gets you is to ensure that the member servers are always going to talk to the domain controller that is nearest to it, and you're not traversing WAN links and going back to your on-prem or wherever the other domain controllers live for the authentication and such. Lastly, security groups and NACLs. So you want to make sure that your domain controller is well protected. There's a couple of considerations for that, and like Lou mentioned, make sure that you're using a private subnet so the domain controllers are not publicly accessible. Also use security groups and or NACLs in combination to restrict traffic that can get into the domain controller. For example, if you're replicating your domain controller from on-prem to AWS, you can configure the security groups on the DCs in AWS such that the only machines that are allowed to talk to it are the DCs that are replicating or the member servers that are sitting in the same VPC. So what you're doing is basically using a layered security approach where you're not allowing traffic to come to a DC that doesn't need to get there. So going from a single region, single VPC into multiple VPCs in a single region, right? So again, some of the same consideration that we talked about is still there. So again, you have to choose between extending your domain or creating a new domain for AWS. But one pattern we see in this example is Common Services VPC or Management VPC. So because there are a lot of VPCs customers may have that run Microsoft application, instead of distributing DCs in every one of those VPCs, sometimes customers choose to centralize the AD services as either management or common VPC services VPC and place the domain controllers there. So what that gets you is one centralized location where all the domain controllers are that you can manage. You can restrict traffic in and out of that subnet and VPC, and you allow all the other VPCs in the same region to talk to that domain controllers. Again, in this example, we're showing VPC peering. So as you guys know, VPC peering is highly available, resilient way to connect to VPCs for communication. And the second VPC can be in the same account or a different account. It doesn't really matter. We're just assuming that you have some Microsoft applications running there. We also show that you can optionally have DCs in those VPC as well, right? So it doesn't mean you have to only deploy it in this fashion, but we see this as one of the common practice. If there is a need for application to have DCs really, really close to them in the same VPC, of course, you can always add additional domain controllers in those VPCs. Now, again, some of those same considerations exist. You need connectivity back to the data center if you're either replicating or have a one-way trust. Again, you're going to have security groups and or NACL protecting your DCs from traffic that doesn't need to get to those DCs. But when it comes to sites and services, there's an interesting approach here as opposed to the first one, right? Because your domain controllers are in a common services VPC and your applications may be in multiple VPCs, you're going to traverse the VPC peering to come here. So one of the approach we see here is to define the entire common services VPC or where the AD is as one site, as opposed to what we did in the first example, which is define each availability zone as one site. Because all the other applications are on the right VPCs are going to traverse that VPC peering link anyway, we think that that's a good compromise between management and simplicity of your Active Directory environment. All right, so how does this work when you have multiple regions, right? Maybe you have more than one region you're operating in, or maybe you have domain controllers that need to be in multi-region because you have Microsoft workload in multiple regions. In this example, again, we go back to how we did similarly in the first and second example, which is within each of the region, you can still deploy the same model, either a single VPC model or a multiple VPC model, but you basically repeat it again in a second region. Because regions could be far away, depending on the regions you choose, we don't want you to use one of the region's domain controller as a highly available solution for applications in another region. Because regions are far away, there's also a latency component that comes into play, which is why we recommend placing domain controllers in every region that you have Microsoft applications running. The connectivity between the region is, again, it's your choice. There are a lot of options there. You can either directly connect to regions using AWS VPN, in which case you're going to be traversing the AWS backbone for that communication. You can also use direct connect. So if you have an on-prem and you have direct connect that's going to both regions, that's perfectly fine too. Then what you end up doing is routing traffic between the two regions by yourself, essentially using your data center as a backhaul. We also recently launched a new service called the Direct Connect Gateway, which allows you to leverage Direct Connect that you have in one region to talk to services in every other region. So the way this works is, you have one Direct Connect that goes to one region. We backhaul the traffic from that region to any other region that you want to go to. So you can leverage that solution as well. Again, the important point is robust communication between the two regions. So you have the AD replication and then also connectivity back to the data center if you're extending or have trust. So what does it look like if you want to go more than one regions and you have a combination of a whole bunch of things, right? We're showing a few examples here. We have two sites, US West 2 and US East 1. They are connected via Direct Connect. And then we also have what we call as an island region, US2, where you don't have a direct connect or no direct connectivity between your data center and the region, but you still have a need to run Microsoft applications, right? So let's start from the left and kind of walk through some of the deployment scenarios we discussed. In the first example, US West 2, you have 3 VPCs and we're running a common VPC, common services VPC model where you see the domain controllers is in one VPC and then you have other VPCs that are peered to this VPC, right? On the second one, US East 1, in addition to that same model, we also have Direct Connect VIF going to each one of the VPC. Well, the biggest difference between the first and the second is in the first one, the Active Directory is available for applications in all 3 VPCs, but there is no direct path from on-premises or your data center to the 2 top VPCs where your application is running. Again, you have to consider your requirements and whether you really need that connectivity or not. But in the second one, because there is a Direct Connect WIF that goes to all 3 VPCs, on-prem can essentially have communication to all VPCs and the VPC that's running the Active Directory. In the last example, we're showing that there could be island VPCs where you don't necessarily need connectivity back to your data center as long as you have connectivity from that VPC or from the region to another region. Again, when you deploy Active Directory, KCC, as you all know, is responsible for building that replication links. And KCC is pretty smart to identify that the domain controllers in US East 1 are the only reachable domain controllers, and it will basically establish replication links to that DC. So essentially what you're doing is replicating either in a mesh fashion or a hub and spoke fashion with the US West 2 and US East 1, but from there using US East 1 as a bridgehead replication to EU West 2. Again, this is if you have a requirement of, I need to run Microsoft application, but I don't need to connect that back to my data center. I just need the application to run there. All right, so we're going to jump into a demo here. We have a multi-region setup for the demo. We're going to show you how we did it and kind of the components that we used. Before we get into the demo, I want to kind of show you what we built, right? So we basically built two regions. We built a region in Ohio and a region in London, and we basically built 4 subnets in each region. Again, we want to split things between availability zones. So if you look at each of the regions, we have 2 private subnets and we have 2 public subnets, right? And each of the subnet is in a different availability zone. We basically placed 4 DCs. We split them between the regions. So this is one Active Directory forest/domain that's spanning multi-region. We also have a VPN device in either of the region and the public subnet. So for the purpose of demo, we chose to just set up a VPN between 2 regions. Again, you have a lot of choice when it comes to that. We also have NAT gateway and RDG, or remote desktop gateway. So what the NAT gateway is doing for us here is it's giving the DCs that are in the private subnet access to things like Windows updates, where you don't expose those DCs to the internet. You have a one-way connection from DC to the internet or Microsoft Windows servers to get an update. But because it's a NAT gateway service, it's not possible for anybody to explicitly connect back into your DCs from the internet, right? And the RDG is just a bastion host for us. So because we need a way to get in and demonstrate what we've built, we basically dropped two RDGs so we can log into them and then show you from there what the DCs look like and what the configuration look like. With that, let's go into the demo here, and we're going to show you what we built. Perfect. One of the things that I didn't mention is the IP overlap. So it'll make your lives really, really easy if any regions you're connecting does not have overlapping IPs. Because you can easily set up VPNs, easily set up direct connect, you can route between them, you don't have to deal with NAT issues. And Active Directory also likes that part, right? So try to get as many overlapping networks, especially if you're going to connect them. Unless it's like an island network, then it's perfectly fine to repeat them. All right, so we're in the Ohio region, as you can see on the top right corner. So basically, if you go to the VPC, I have one VPC that I built, and I just chose a 10.0.0/21 IP space. I mean, again, it's just a demo, and I just wanted to pick an IP space that's not overlapping with the other region. And if you look at the subnets, I basically have 4 subnets defined. So I have 2 private subnets, 2 public subnets. But if you look on the far right, you'll see that 2 of them are in 2A and 2B, and same way for the other one. So we're splitting the subnets so we can drop things into AZs. Again, for the CIDR ranges, I just made it really simple. Everything is a /24 there, so I have 4/24 subnets. So when you get to the route table, so this is where, as you guys know, you define whether a subnet is a private subnet or a public subnet, right? So if you look at the private subnet, I have 2 subnets that are associated with this route table, so I have the 2 private subnets. And then if you look at the routing, it basically has the VPC address itself, which is local. And then you have the 0.0, which is pointing to the NAT gateway. So this is where you get your one-way traffic out to the internet for updates and things like that, but no path in. We also have another destination IP space of 172.16. So this is the IP space of my other region, which is my London region, right? And the way we are directing traffic between the two is by using our own VPN instances. So what we're doing is adding a route table entry for all the destination network to point to this particular ENI or instance, and that is actually a VPN termination device, which will take the traffic and take it all the way to the other region and drop it on the other side. If you go over to the other side, so now we're in the London region. Again, exactly the same setup. We have one VPC, which is defined as the 172.16 space, non-overlapping with the first one. We have the same for We have the same 4 subnets, and then route table defined exactly as they are. So this is how we establish connectivity between the two. Again, as Lou mentioned, you can automate this entire build by using CloudFormation, right? You can build this whole thing out and just have the option of you typing IPs when you deploy the template. So this will allow you to build whatever I built in literally a matter of 5 minutes, 10 minutes. You can get the whole thing set up there. With that, I'll pass it on to Lou, who's going to demonstrate the Active Directory and what he has set up from that perspective.
Thank you, Vinod. So now that we have an understanding of what our networking infrastructure looks like from the AWS perspective, let's take a look at what it looks like from an EC2 or an Active Directory perspective on AWS. So for that, I'll switch over to the EC2 dashboard. I'm currently in the Ohio region. I'm going to select my 4 running instances, and you'll see here the various domain controllers that we have running. You see the VPN appliance that we use, as well as a remote desktop gateway service that we set up so that we can remotely access those domain controllers that are secure in the private subnet. So notice that DC1 is on availability zone 2A and DC2 is on availability zone 2B. Again, ensuring that Active Directory is highly available, so that if any one of those availability zones became unavailable for some reason, or that domain controller in that AZ failed for some reason, the other domain controller would continue to function. And if your application is highly available and well architected, then it would continue to function because it would be leveraging the domain controller in the other availability zone as well. So definitely something that we encourage our customers to do when deploying Active Directory on AWS. Now the same applies to the London region. So notice now I switched over to London. If I go to the EC2 dashboard and select my running instances, you'll notice on this side I have a similar configuration. I have DC3 and DC4, again on separate availability zones. We have our VPN appliance, and then we have our remote desktop gateway service that's the only one that's able to access those domain controllers in that particular region. So with that, let's take a look at the servers that I'm connected to. So I have my remote desktop connection. See how that looks? A little bit small, so I'll zoom in where I can. So notice here I have Active Directory sites and services open. We want this all to replicate as quickly as possible in this particular example. So we just leverage the default IP site link and put all our sites in that particular site link. But depending on your network, again, your network requirements, what your network infrastructure looks like, you may have additional sites defined, additional site links defined with those sites connected with one another, and maybe even site link bridges connected so that you can replicate your Active Directory. You can allow KCC to develop replication connections the way you desire based on how your network is laid out, whether you're using an on-premises hybrid connection, using multiple regions, leveraging MPLS, for example, if you have that running on in your own environment on-prem. You can define how that takes place. In this example, because it's all in the cloud, it's 2 regions, we're allowing that to replicate with one another as quickly and efficiently as possible. So notice I have different sites. Let me zoom in here, see if this helps a little bit. I have different sites configured for each of these locations. So EU West 2 is basically the London region, AZ1, EU West 2, AZ2, additional sites. Each of those sites has its own domain controllers. So if I expand EU West 2, AZ1, notice I have DC3 in there. EU West 2, AZ2, I have DC4. And then for US East 2, which is the Ohio region, I have DC1. And US E2, AZ2, I have DC2. And then in my subnets, I have all the different subnets that we've created within AWS, both the 10.0, 1.0 subnet space as well as the 172.16 subnet space, so that each of those subnets, those /24s, are defined and they're associated with the appropriate Active Directory site so that any member servers authenticate locally and don't traverse across AZ unnecessarily. So there's an example of that. Now I'll show you, how the replication looks. So here we have rep admin, a replication summary. We see DC 1, 2, 3, and 4. So let's just run that, and we see that everything's replicating. Largest delta is being under 15 minutes. So within 15 minutes, all these domain controllers are replicating any changes with one another. So there's just an example of how that is set up. Now what I'd like to show you as well is how easily that can be done. So we talked about the quick starts. We have these automated deployment solutions that solutions architects at AWS and partners have built using best practices and security in mind. So these quick starts basically are CloudFormation templates that we've deployed for various solutions, not only for Microsoft or Windows workloads like Active Directory, but many others outside of the Windows platform as well. But for Windows specifically, we do have an Active Directory domain services quick start. And what this allows you to do is to deploy that Active Directory environment that I just showed you via a template. It's infrastructure as code. You enter a few IP addresses, your domain name, click next, and it launches. And I'll just show you what that looks like. But we have several different scenarios in this particular quick start. So if you notice there, we have scenario 1, which is deploying and managing your own AD/DS installation on AWS. So you would use this if you were deploying a net new Active Directory environment or forest on AWS. You have the option of deploying into a new VPC, so it'll actually create everything for you to support this Active Directory environment, or you can launch into an existing VPC. So that's what I did. Since Vinod built out the networking infrastructure, including the VPN, which again can be built using CloudFormation, and we have a solution for that as well, setting up transit VPCs, which is in our deck, and you'll have access to those links so you can look at those solutions. But since that was already built, I was able to just leverage the existing environment that was configured in AWS. So if I click on this, and this is the Ohio region, so I did this in Ohio, that's where DC1 and DC2 are located. If I click on Launch an Existing VPC, it's going to take me straight into the CloudFormation service. So again, CloudFormation is a service that allows you to deploy AWS infrastructure as code. So notice it's specifying a template that exists on S3 that, again, we've created, and this is publicly available to everyone. And then you simply click Next. And here you have the several different parameters that you need to fill out. So this is scenario 1. You can give it whatever name you want. But notice that there are some defaults that are already selected for you, but you can certainly change these. So since this environment already exists, what I did is I selected the drop-down VPC ID, and I selected the existing VPC that had been created earlier. And then I changed the VPC CIDR to match what was selected here, since it's already existed. And I did that for everything else beneath it. For the private subnets, there's already private subnets defined, so I selected those, selected the public subnets, selected my key pair, the domain controller name. All this stuff is changeable, so you can give it whatever names you might have according to your naming standards. And the IP addresses within those subnets. And then I specified the domain DNS name, as well as the NetBIOS name, the restore password, the domain admin, as well as domain admin password, and then just click Next. And then launched this CloudFormation template, and it built that entire Active Directory environment in the Ohio region in a matter of just a couple hours for me, all without me having to do anything on it. Active Directory being enabled, those sites being created within AWS. So once I deployed, and you see here the result of the stack creation. So this was the ADDSUS in Ohio, created successfully. Once you deploy that, and you want to deploy in another region, but you want to connect that region to your existing Active Directory deployment, whether it's on-prem or in AWS, I use scenario number 2. And scenario number 2 extends your on-premises or your existing AD on AWS to a new region or within the same region or another VPC. So again, what I did here in the scenarios, I selected an existing VPC because the networking infrastructure was already set up. So I clicked on this and clicked Next. And Again, it gave me the options of selecting the existing VPCs, existing subnets, but notice in this one, there's no option for setting a domain name. There's no DNS domain name, no NetBIOS name, and that's because this is going to deploy into an existing VPC. So one thing to keep in mind with this deployment is it creates the security groups, it creates everything that's required for Active Directory. It deploys the Windows EC2 instances, but it does not enable them as domain controllers like it did in the previous quick start or the previous scenario. And the reason is that you need to go into those domain controllers and now run DC promo on them, or add the role, run DC promo on them, and then point them to the name of your existing Active Directory, whether it's in the cloud or on AWS. Once you do that, they start syncing with one another, AD replicates, and now they're replicating with one another the way that I showed you in the demo there while I was RDPing into those servers. So all this took just a matter of a few hours just to deploy Active Directory globally. This is from the US to London, and it was done in just a matter of a few hours. Now, I've been on the other side, just like all of us, when we were having to deal with data centers and build servers, rack servers, and all that stuff, and remember how long it took to deploy Active Directory globally in those days. Now you can do it in a matter of a few hours, and all in an automated fashion. So that's what we wanted to show you there. We'll switch back to the presentation. And let's see. There we go.
Just to summarize what we talked about today in the session, ADDS is required to support all the Windows workload that people are moving to AWS. So you want a robust Active Directory infrastructure in AWS to support all these workloads. Remember that all of the Active Directory best practices still applies as you deploy them in AWS. They don't go away, they still apply. But on top of that, we also apply AWS best practices while we deploy the Active Directory. Lou talked about Quick Start, so leverage all these tools. You can deploy them not only reliably and scalably, but also really quickly, right? AWS is the best platform to host ADDS. Take advantage of that. Take advantage of all the features we have, the availability zones, the security groups, everything you have to deploy them. Finally, we want to give you some links that we have used in this presentation. So the Transit VPC solution that allows you to build a mesh of VPNs to connect multiple regions. We also have the AD Quick Start link that Lou used to deploy everything today. Lastly, we have some related sessions that you might be interested in signing up. These are related to Microsoft workload. I want to call attention to the first one especially. It's the Active Directory service for Microsoft AD Deep Dive. So this is the session you want to attend if you're interested in AWS Managed AD. So if you're interested in that and interested in knowing more about it, that's a 400 level session. So I recommend you sign up if that spot's left. And that'll talk about all the managed service and not AD on EC2. Again, we want to thank everybody for coming today and attending this session. We'll be here if you guys have any questions. We're here to answer.
Yep.
So.
Thank you, guys.
Thank you.